In this video, I will show you how to graph a cotangent function that is reflected over the x-axis and has a change in, there's a vertical stretch, there's a change in period, there's a phase shift, and there's a vertical shift. So this function just has it all. Buckle up. First of all, I need to rewrite this mess. I'm not feeling the way this is set up. I see that there's going to be a b value. Hold on. That was my alarm telling me that it was time to cut off the Wi-Fi, the internet, to my kids because it's 9 p.m. and they need to start settling down, thinking about bed. Yeah, be glad you don't live here. Alright, so I need to, well, first of all, I realize that there's like a 1 in front of this x, so I'm looking at this as 1/3 x, and that 1/3 needs to go out in front of parentheses. Got to factor that out. That's going to leave behind x minus something. Now, when I bring out this 1/3, I need to take this part, the pi over 12, and divide by 1/3. So I'm doing pi over 12 divided by 1/3. But when you divide, you multiply by the reciprocal. So that's going to be 3 pi over 12, which is going to be pi over 4. So that's why I'm going to have x minus pi over 4 right now. So all of that should be in parentheses. So I've got this parentheses inside of parentheses. It's perfectly normal. Everybody just calm down. And so then I've got, I didn't leave myself much space, but I've got my cotangent and my -2 like in the front. Y equals, I'm going to squeeze that in, not very pretty, but I'm going to deal with it. Now, because of the negative sign that's in the front, I know I have a reflection, and that's one of the things I'm being asked. So I'm going to go ahead and say yes, there's a reflection over the x-axis. X-axis. All right, reflection over the x-axis. Now, time to calculate the period. The period is always the normal period divided by the b value. For tangent and cotangent, the normal period is pi. Alright, unlike sine and cosine that have a period of 2 pi. So that's why I'm going to do pi divided by the b value. So the period is going to be pi divided by 1/3. Alright, but that means pi times 3 or 3 pi. So the period is 3 pi. Okay, good to know. The phase shift is this h value right here. That's the phase shift. So it is the opposite sign of what you see in the equation. So the phase shift is positive pi over 4 to the right. Alright, there's also a vertical shift. This k value. Right, like that's the h value, that's the k value. K value tells us that we have a vertical shift of up 3. We will write the equation for all the vertical asymptotes at the end of the problem. It's easier to do when you're looking at a graph. Alright, speaking of graph, let's do this. Whenever there's a phase shift, then I like to start with the phase shift. Okay, this is up 3. Alright, I'm just seeing how much space I'm going to need. Alright, so I have a phase shift of positive pi over 4. So normally with tangent and cotangent, I put 0 right in the middle of my graph. Alright, normally I would go right here and I'd put 0 and we have to do 2 periods. Whenever you do tangent and cotangent, I need not 1 period but 2 periods, one to the right and one to the left. But when there's a phase shift, I start at the phase shift. So instead of putting 0 here, I'm going to put pi over 4 here. Okay, so this is going to be pi over 4. Now, if I go 4 positions to the right, that should be the end of a period. So here I go. 1, 2, 3, 4. All right, that should be the end of one period. If I go 4 positions to the left, that should be the end of another period going to the left. So 1, 2, 3, 4. That should be the end of another period. Now, I need to know what these numbers are, though. I'm not playing around. I need to label stuff. So, when there's a phase shift, the way I calculate is I realize that each one of these marks represents a quarter of a period, a quarter period. So, I need to find out what a quarter of a period is. So let's see, what is a quarter period? Quarter period. Well, the period is 3 pi. So a quarter period is going to be 1/4 of 3 pi. Alright, also known as 3 pi over 4. So that's my quarter period. Well, I'm in luck. Like normally I have to do some multiplying by the numerator and denominator of one or both of these expressions to make like denominators, but look at this. My phase shift and my quarter period, they already have like denominators. So that's going to make my life a lot easier. So, okay, I'm going to leave myself space just in case I must replace, no, I'm sorry, I just got carried away with my rhyming. Just in case I need to reduce anything, I'm going to put my numbers low and then reduce up high. So my phase shift is where I begin, pi over 4. Every one of these positions going to the right is increasing by a quarter of a period. So I should be able to add a quarter period, add 3 pi over 4. Well, 1 pi over 4 plus 3 pi over 4 is 4 pi over 4. Alright, add another 3 and you have 7 pi over 4. Add another 3 and you have 10 pi over 4. Add another 3 and you have 13 pi over 4. Alright, now I'm going to reduce like I was saying. 4 pi over 4 is simply pi. 7 pi over 4 does not reduce. 10 pi over 4 reduces to 5 pi over 2. And 13 pi over 4 does not reduce. Okay, so I'm going to use those 5x values when I draw my graph later. But like I said, I need 2 periods. That's 1 period so far. I want a period going to the left as well. So going to the left, instead of increasing by a quarter period, 3 pi over 4, I'm going to decrease. I'm going to subtract 3 pi over 4. 1 minus 3 is negative 2. So this next mark over here should be negative 2 pi over 4. Alright, minus 3 again is minus 5 pi over 4. Minus 3 again is negative 8 pi over 4. And minus 3 again is negative 11 pi over 4. Now I have left myself space to reduce that as well. So this is going to reduce to negative pi over 2. This one does not reduce, so I'll just put negative 5 pi over 4. This reduces to negative 2 pi. And this one does not reduce, so I'll just put negative 11 pi over 4. So these are the 9 values I'm going to use to graph 2 periods of this function. Okay, Now I've already taken care of the phase shift. I haven't done anything with the vertical shift yet, and I'm going to deal with that in just a second. Okay, now normally when I'm graphing the, what function am I graphing? The cotangent function. I've memorized, well, there's two things I sort of memorized together. I've memorized what the tangent function looks like. Alright, one period of the tangent function. Okay, little tutorial here. And here's one period of the cotangent function. Alright, here's what we've learned. The tangent function begins and ends on the midline, and then there's a vertical asymptote down the middle. And then you increase towards the asymptote, and you increase away from the asymptote. That's what one period of the tangent function looks like. Now for the cotangent function, everything is reversed. Reverse, reverse! That's probably before your time. You guys have no idea what I'm talking about. Anyway, instead of beginning and ending with a point on the midline, I begin and end with an asymptote when I'm doing cotangent. Instead of having an asymptote in the middle, I have a point on the midline in the middle. And instead of increasing towards the asymptote, for cotangent, I decrease towards the asymptotes. Okay, so this is what one period of the cotangent function is going to look like. Alright, so this is what I'm graphing. I'm going to begin and end with an asymptote, and there should be a point in the middle on the midline. So just keep this picture in your mind. Begin and end each period with a vertical asymptote. Okay, with a point in the middle. Okay, so remember, one of my periods started right here at the phase shift at pi over 4. So I'm going to begin and end every period with a vertical asymptote for cotangent. Alright, so there should be a vertical asymptote at the beginning of this period, and there should be a vertical asymptote at the end of this period. Okay, and then look, right in the middle, there should be a point. Alright, there should be a point right in the middle. However, that point needs to be on the midline, and I haven't drawn the midline yet. So just keep that in mind for later, that there should be a point right in the middle. But I gotta hold my horses, gotta cool my jets, and I'll put that point once I have the midline done. Where was I? More asymptotes. Okay, this over here was also the beginning of a period. Okay, because I'm doing two periods. So I need to begin and end every period with an asymptote. So here, I have an asymptote sandwich on the left for cotangent, and I have an asymptote sandwich on the right. Now I need the midline so that I can put my dots right in the middle. But in order to have the midline, I'm also going to need the y-axis. So let's go ahead and get that y-axis out of the way. The y-axis is always at 0. Now I don't see 0 here among my values. However, I see it goes from negative to positive right here, which tells me that 0 is somewhere in between. So I'm going to go ahead and draw my y-axis right here between these. Okay, now just remember, this is not an asymptote. I'm just putting this here so I can mark my amplitude and my vertical shift. Okay, so don't treat it like an asymptote or anything like that. Okay, now what is my midline going to be? Well, I'm going to go up 3, And then I better keep in mind that my amplitude is going to be 2. So that's a total of 5. So I need to leave space for 5 positions here. Okay, so here I go. 1, 2, 3, 4, 5. Okay, that's what I'm going to need. Now, so first of all, my midline. So the vertical shift is up 3. So I'm going to have a midline here at 3. Okay, so that's going to look like this. Here's my midline. Okay, here's my midline. Okay, now, in addition to that, I've got this A value that I'm going to be worried about. All right, my A value always happens. See, my A value is -2, so that means I need to go 2 above and below the midline. So what I'm doing now is very, very optional. All right, but 2 up from the midline is here at 5. So I'm just going to put this very light line that you can barely see. That's optional. You don't have to do the yellow line. All right, and if I go 2 below, that would be here at 1. So the yellow line is optional, but the 5 and the 1 and the 3, those have to be labeled on the y-axis for sure. All right, so this yellow position is going to be important when I do my graph later. So I like to draw them. All right, now I am ready to go ahead and do my graph. Okay. We drew these asymptotes at the beginning and end of every period. Now, in the middle of every period, there should be a point on the midline. So now that I've got the midline, I can go right to the middle of the period, right here at 7 pi over 4, and there should be a point there. Okay, same thing on the left side. The middle of my period is here at -5 pi over 4. All right, ignore the y-axis. There's my vertical asymptote. There's another vertical asymptote. This is right in the middle, so there should be a point right here. All right, so these 2 points I'm going to use to guide my graph. Now be careful. Normally, tangent is increasing and cotangent is a decreasing function. So normally, tangent rises towards the asymptotes like this, and cotangent falls. However, this time it's going to be upside down because of this negative sign, all right, in the front. This is a reflection over the x-axis. So whereas cotangent normally falls towards the asymptote, not this time, no sir. The cotangent function this time is going to rise toward the asymptote because it's upside down. Now, I need an additional point though for this. Halfway over at -pi over 2, the graph should pass through the A value. That's why I put these yellow lines here. So halfway over, I should have a point right here, okay, at 5. Okay, so I'm going to rise, but I'm going to make sure that I hit that point as I go. And I approach the asymptotes. And so I'm going to do the same thing on the other side. I'm going to rise up from the bottom as I approach this point. But halfway over, I should be 2 below the midline because of the A value of -2. So that's why I put this yellow line here to remind me of that. I should have a point right here. So as I rise from the asymptote, I'm going to make sure that I hit that point. Okay, so there is one period of my upside down and very shifted cotangent function. Okay, and just please understand, I am approaching this vertical asymptote over here. I'm not approaching like the y-axis or anything like that. Okay, I'm going right over to that asymptote. So let's do the same thing over here. I'm going to rise towards this asymptote, but halfway over I should be here at this A value above the midline. That's the yellow line. So as I rise, I'm going to make sure that I hit that point. Alright, I wish I had made my asymptotes just a little bit longer. Okay, and then I'm going to do the same thing on the other side. Alright, I'm going to rise up from the asymptote, but halfway over I should be here, two below the midline because of the A value. So I'm going to make sure that I hit that point as I go. Alright, so there it is. This is what 2 periods of this cotangent function should look like. Alright, now we have to answer one additional question about the vertical asymptotes. Vertical asymptotes are always x equals whatever it is. I like to pick my first positive vertical asymptote, so I see that I have one here at pi over 4. So I'm going to put pi over 4, and then I'm going to add multiples of something. How far is it going to be until I get to the next vertical asymptote? Well, remember this branch over here, this is one full period of the cotangent. So from asymptote to asymptote, it takes a full period to get to the next asymptote. So that's why I'm going to add a full period, and then I'm going to add a multiplier to do another period and another period and another period. So what was the period again? For this function, the period is 3 pi. So that's why I'm going to add 3 pi, and then I'm going to put an n on there to represent an integer. It's a multiplier. Alright, integers can be positive or negative. So this could be 1, 2, 3, 4, or even 0, or negative 1, negative 2, negative 3, negative 4. Alright, if n is 1, then that's giving me the next one over to the right. If n is negative 1, then that will give me the asymptote to the left, and so on. Alright, anyway, that's it for problem number 7 that we've been doing this entire time. That is how you graph a cotangent function. Alright, this is a long video for one problem. I hope you have been thoroughly educated. The next video will be about graphing cosecant. I'll see you on the next video.